what are key elements to include when you're thinking about doing your own inquiry-based lab? Well, as we've already alluded to, it's really important to include instructor guidance to help students develop inquiry skills. As we've said, the kinds of thinking, the activities that we're asking students to do are really challenging, and so we need to provide support and guidance to help them define a research problem, to help them formulate hypotheses, to help them plan an experiment. We can't just toss them in and expect them to be able to do these challenging things without helping them figure out, practice, and learn how to do these things. It's also very important to include an opportunity for peer-to-peer interactions and teaching. Now, what this looks like can vary. So you can have multiple short interactions with peers where they work in pairs that change from week to week, or you can have more long-term collaborations, as we saw in the biological sciences example, where 8 peers work together throughout the course of the semester. You can also simply incorporate opportunities for the students to present to their peers and respond to their peers' feedback. So exactly what that peer-to-peer instruction and teaching looks like can vary, but it's very important to include that element. It's also important to include an opportunity for students to give a summative presentation of their work, either oral or written. As we talked about earlier, this opportunity to sort of synthesize a whole presentation of their work gives the students the opportunity to practice bringing elements together, evaluating what's important to talk about, and to present the types of analysis that they did. And so providing this opportunity helps solidify students' understanding of the whole process. What sorts of challenges can you expect when you're developing an inquiry-based lab? Well, they look a whole lot like the sorts of challenges you'll encounter in doing your own scientific research. You're almost certain to encounter messy data. You're almost certain to encounter unexpected results. And you're very likely, because you're dealing with novices, you're very likely to encounter questions that are too broad. In other words, you're likely to encounter a little bit of chaos. But by incorporating the sorts of structure and support that we've been talking about, you can help use this chaos in service of your students' learning. To help you deal with these challenges, you should rely on existing communities of scholars within your discipline who can help you avoid pitfalls, point you to good practices, and point you to really good existing examples of inquiry-based labs. To help you get started finding these communities of scholars, we've provided some resources in the PDF associated with this course. There are some general resources, and then there are some discipline-specific resources that may help you get started with inquiry-based labs within those disciplines. These resources range all the way from astronomy through computer science, earth and environmental science, engineering through physics. In this PDF, we've also provided selected references so that if you want to do more reading to learn more about policy documents that define inquiry and its implementation and teaching, those references are available. If you want to read more about this definition of the elements of inquiry, those references are available. We've also provided selected references that demonstrate the benefits of inquiry-based lab instruction, and finally, selected references on general teaching and learning principles.